Dear students, so welcome. Let's discuss briefly about some properties of light. We have red light here, and there are two different materials. The first material on top is air, and the below material it can be glass and other transparent material, but mostly we prefer glass in this case. And as you can see, there are three types of lights here. There's light that is transmitted, so incident light that is coming towards the glass surface. There is refracted light that is bending because of transition from one medium to another. And there is another one, the third, which is reflected. The reflection happens because of the nature of the surface in contact. If this surface is very rough, the reflected light will be minimal, will be small. But if the surface is very smooth, then we have more reflection. But again, it also depends on the angle. So for example, if you see here, if I turn my source at a certain angle, you see also the changes. So as you can see, if I change the angle, if I change the incident angle, the reflected angle changes and the refracted angle also changes. And this will also determine the amount of light that is actually passing through our sample. This is very important to take into account. Let's say, for example, I'm trying to track the intensity of light here. For example, as you can see now, the intensity is 84. But if let's say, make the angle smaller, now we have 56.8. If I make the angle smaller, you can see that the intensity is increasing. The intensity of refracted light is increasing actually. If I turn it this way, the intensity of refracted light is decreasing. So this means if the intensity of refracted light is decreasing, it means the intensity of reflected light, which is this one, is increasing. So these are important things to take into account, especially in a simple way when we are talking about reflection, diffraction of light. Thank you very much. Dear students, let's discuss briefly about transmission of light. When we talk about transmission, it means we have light that is actually penetrating the sample and going to the other side. So light that is transmitted, for example, if we turn this on, you can see the green light. Of course, we can change this, but for now, let's just use green light. As you can see, this light passes through the sample to the other side. So this is transmitted light. So it goes through the sample and then it is transmitted. If you see here on the screen, we record the amount of light that is transmitted. As you can see now, is 31.19%. It means a lot of light is actually absorbed here. But again, if we increase the sample, if we make the sample larger, you can see the amount of transmitted light keeps decreasing. So the larger the sample, the more light is absorbed here, and then the less light is transmitted. So when we talk about concept of transmission, that is what it means, that you have light that is going towards the sample, is shined on the sample, and if it's absorbed, the portion that remains is the one that gets to the other side, gets outside the sample, and that is what transmission is all about. So in some cases, there are a combination of several phenomena. You can have absorption, you can have reflection, depending on the walls and the nature of these surfaces, and then you have transmission at the end of the day. So if the sample is highly absorbing, then you will have less transmitted light. Or if the sample is more scattering, you'll have less transmitted light. But if the sample is clear, like let's say if you are talking about water, for example, then it's easy to actually have more and more transmitted light. Thank you for listening.